to say a couple things before I have Chris Pedersen, I see, is on the phone here too, but I'm going to mute everybody, and then I'm going to unmute Chris and just make sure he's unmuted before. Chris, are you unmuted now?
I give up, am I?
Yeah, you're fine. You're terrific. We're going to go to your presentation in just a second here, but I'm going to move on to the desktop and show a couple other things, and then we'll talk about Kimray here.
Can I ask one question for
Absolutely.
the previous speaker?
Absolutely.
To what extent are materials which are volatile at the operating temperature of the filters a factor in different applications?
That's a good question, and let's say that because I just unmuted everybody, including Richard. So let's save that to the discussion that we're going to get into in a minute here. One thing I just did want to show up is another Mercury technology that we covered in our webinar a few months ago, and the fixed bed sorbent technology is now available from Gore, and I noticed today, or yesterday rather, there were, maybe it was a few days ago, an announcement by URS that they are going to incorporate this technology in systems that URS is offering to the power industry. So this particular product has now gone from, you know, the demonstration stage to the commercialization. So I would refer our viewers and readers to our presentation of a few months ago, but essentially it's a downstream polymer composite that captures the little bit of mercury that escapes the scrubber. And again, this whole theme of moving beyond the 90% removals to much higher levels in order to preserve the future of coal, this is one way certainly to do that. And that being said, Chris, let's go on with a discussion of a very interesting approach that can compete with wet precipitators. So tell us a little bit about AeroSep and the approach that you people use there at Kimray.
Okay. Well, I need to back up just. Can you move the slide up a little bit so we or down, whichever, so we have a little more of the cross section further down?
Down to the cross section here, I believe is somewhere. Let's see, right there.
Right.
Yeah. Okay.
Yeah. Just needs to go down a little bit.
More down further.
Yeah. Or the other direction, anyhow.
Okay, so we have the whole.
I want to see the part with it. Yeah, that's fine. Perfect.
Yeah. Okay, great.
Okay. Before you can understand this, there's a little bit. I got to give you a little background. Kimray produces a structure made out of monofilaments, and the structure is made out of monofilaments that range in size from 50 microns to about 900 microns in size. And you can think of the structure as two sets of parallel single fibers crosswise to each other. And it's in layers. So you have two sets of these fibers crosswise to each other. And we produce that here in the United States and have been for nearly 40 years. The AeroSep technology utilizes the capacity of the finer materials to collect aerosols in the 1 to 2 micron and below and submicron region. We can collect particles below 1 micron or at 1 micron at very high efficiencies without any great difficulty. And we've got, I don't know how many in that size, but worldwide we have somewhat over 20,000 installations of our different technologies. What we have here, we have first of all the concept drawing in the bottom, where we're and this was applied on an incinerator many years ago. It was it's 20 years old this year, I think. But basically, we're taking out hydrochloric acid with plain water, sulfur dioxide with caustic, and then where you see the Aerocept section, it says we're actually spraying in very, very fine water particles, water drops. The water drops vaporize, the vapor transfers to the particles. The particles get a little bit bigger. They grow very rapidly to about 1 micron, and then the growth, much like cloud physics, slows down dramatically. But then the stage 3 easily removes the 1 micron particles, and it converts them from more or less 1 micron to 200 or 300 or 400 microns, which you remove with a simple Chemery technology, a mist eliminator. And this technology is used in a wide variety of applications. This is one. This technology is used, for example, on P2O5 combustion, where fiber bed candles aren't appropriate due to solids. It's used on fumed salts. It's been used on ammonium sulfite submicron aerosols from power plant, by the way. And it's used in quite a few municipal waste incinerators in Europe. It's, for example, used in Brugg, Berlin, Munich North, which, as far as I know, is the largest unit of its type in the world. We have more or less 20 or so of these installations, all in Europe. None of this has ever been used in the United States on any kind of power generation operations. But that's the basic Aerocept technology. We finished a pilot plant last year, which where they're using an oxymethane torch to cut through stainless steel, and it generated a very high amount of 100% submicron particles, well down into the nanoparticle range, which they didn't actually expect. So it was a very considerable problem. We did a pilot plant on that, and we're able, with this technology, to remove something in the order of 95% of the 100% submicron particles.
How would that compare, for instance, to the sulfuric acid mist, which, you know, the power industry has been installing wet precipitators after the fact? They've got a scrubber system, and they still have a plume. Particularly, you know, the SCR is generated. It converts about 1% of the SO2 to SO3, and then downstream of your scrubber, then you've got this sulfuric acid mist, blue plume. You know, how effective would the Aerocept be on that?
Well, it's been used for that kind of application. That's perhaps the easiest application we ever run into. From our standpoint, the technology works perfectly on that application, and the pilot plants are available to test it. But I will say this, first of all, Chemery is not active in power plants, okay? And this Chemery, which is the company I formed, I'm CEO, is not actually going to do power plant activities. We're going to work with somebody else to develop that market. But we're focused on other markets. For example, chrome, and I'll mention one thing about chrome. There's another chrome. We're MAC for chrome +6, and it's used in essentially every chrome application in North America, chrome plating operation in North America. Although I doubt more than 2 or 3 of the listeners have heard of us, Chemery technology is used on actually the world's largest installation that removes mercury for mercury removal, and we have a new mercury removal process addition for that. and it's also used in the world's largest phosphoric acid plant. So those are the markets that Kimmery is focused on, will continue to focus on. But the technology for fine particulate removal, this technology, AeroSep, is very suitable for any type of situation where the particulate is either water-soluble or has a coating, such as sulfuric acid, which is typical from most sources. Does not work for submicron oil particles, for example. It doesn't apply to that.
But high on the mercury removal efficiency, you're saying?
Yeah, that's actually a slightly different technology. It uses AeroSep, but there's an additional step to it. It's based on a modification of the calomel process that's used extensively in smelting operations.
But for
I gave a paper on that last year.
Good. Yeah, we'd like to get a copy of that. But I think for our viewers who are interested in removing mercury and sulfuric acid mist, and these are major problems for the industry, this is of great interest. The other thing, you mentioned the chromium-6. The power plants emit a great deal more chromium than all 5,000 of the chromium electroplaters by orders of magnitude. But the initial claim or thought was that the chromium was not in the chromium-6 form, but and not toxic as toxic. But more recent studies do show the toxicity, and there was even a study from one of the power plants in the Indiana area that claimed that putting on the scrubber on the power plant was actually going to increase the chromium toxic contamination of the neighborhood, because the chromium-6, would be in a gas that was at saturated gas temperatures, and therefore wouldn't have the lift and wouldn't drift as far, and so you'd have a concentrated amount of the chromium-6. So that's kind of an interesting aside there. But the power industry is not, is a major generator of chromium-6.
In the pilot study I referenced, that was a real issue. There wasn't a lot of buoyancy, and there's real serious chrome problems for quite a wide area around the facility. In the facilities on the garbage burning plants, municipal waste planning plants, all of these have been running for decades, so they can get a long history of service, and I've been to quite a few of them. They're all removing all kinds of submicron particulate. These devices are the last thing on the system, our AeroSep systems. Although they don't call them AeroSep because they were sold under license. We had a licensee at the time called Simulate, and they're all Simulate installations. They're all specifically for submicron aerosols, and they're collecting dioxins and mercury and chrome and all of the compounds that were volatilized and then subsequently recondensed or emitted. So it's a real plethora of compounds, and it varies, of course, from location to location what's actually collected.
And basically, to summarize what I'm hearing you say is you think you have a technology that would be very applicable to the power industry. It's just not the area that you focused on, and you'll be looking for partners that can take this technology and make the most of it in the power industry. Is that correct? That's
correct. We're a world leader in phosphate fertilizer, air pollution control, becoming one in nitrogenous fertilizer. We're a world leader in hydrochloric acid, particularly for electronics production. And we're focused 100% really on those markets. And we've got, frankly, all the business we can handle currently for those. So this is not something the Kimmery, existing Kimmery, is going to undertake. We're looking for someone to work with on that and develop it. We do have a pilot plant which will easily show the applicability and the usability. But these units that are running on in garbage burning, I mean, the youngest of them is running 20 years, and some of them have been running almost 30. And the media typically last anywhere from 5 to 10 years. Before change-outs, they run at low pressure drops. They're very power effective and cost effective methodologies, and they're proven to work.
Very interesting. I'm going to open up the discussion to the floor at this point in time, so we'll unmute everybody and take questions from the floor.
All right.
While we're waiting for other questions, Richard, you may want to answer Chris's question relative to the VOCs, and then Partha Pell also had a question about whether the ceramic unit could be used with spray dryer scrubbers with an exit temperature of 80 degrees C. So we're talking about one question on the VOCs and the other one on in some combination. I suppose what you're really saying is going to be probably in replacement of the spray dryer. But please address those two issues if you would.
Let me just interject something, if I may. I wasn't necessarily referring to VOCs. I was referring to any kind of volatile material.
Okay.
There are a number, obviously, of elemental inorganic materials that are volatile at those temperatures. And we've had cases that we've dealt with where there would be a significant level of volatile inorganics at those temperatures.
Yeah, Richard, if you could address that question, but I see Partha Pell was actually asking John Lemcooler about the use of the bromine with dry scrubber. So we'll first get Richard's answer, and then we'll get John's answer there.
Yeah, just to come back in there on the VOCs, we've done a little bit of work on VOCs. It will depend on what the VOC content is. But in general, the materials themselves, the ceramic material themselves, is mostly inert. So in general, we'll operate in quite a wide variety of conditions. Of course, it's resistant to 900 C. So even if we've had instances where there's been fires or there's been volatile burnouts in some systems. Of course, then effectively some sintering of the element will take place, but it still will remain porous. So therefore, it will still pass gas, etc., through it. So we've dealt with situations like that before. On spray dryers at 80 degrees C, I think that was the question from memory. I've got less. That would be a little bit of a concern. I'd be concerned anything that would go into below dew point or at low temperature. These are designed for operated at high temperature, and the reason for that is primarily low temperature scenarios going below dew point, and you'd have issues with, I think, perhaps corrosion there as well. But I'd be skeptical of working below, let's say, at low temperatures with these elements. I think I'd be much more comfortable working. Most of our applications are in the region of, I think I showed you one application of 155 degrees centigrade. That's at the lower end of our filtration spectrum, operating up to about 500 centigrade. So we've got plenty of references worldwide between those ranges at the moment.
Yeah, and I was the one that confused to whom the question was, and obviously the advantage is operating at the high temperature. But John, would you like to address the fact of using the bromine in conjunction with spray dryer scrubbers?
I mean, specifically, what is the specific? I mean, in utilization with them, I mean those could be
Could you
they
mix
could work
the calcium? Could you mix the calcium bromide and inject it into the spray dryer scrubber along with the lime? Is I think the question, or is the question she?
Okay. Well, okay. Thanks for clarifying. Yeah, I mean, I would. It would obviously depend on the specific situation you're talking about, but I mean, you know, some of the things that you could do would be injection down from that too, because if you're removing, say, sulfur species, then that may help make the bromide. You know, you get less competing reactions and things going on. So it would really depend on how and where you're doing it.
So it could be done simultaneously or separately in conjunction with a spray dryer scrubber operation.
Yeah, I mean, there's been discussions and then people have asked me those questions before. I mean, I guess it would really, it's kind of a hard question to answer unless you knew the specific situation you're talking about. But yeah, I think conceptually, I would say it should work.
Other questions or thoughts?